So, what if I told you that the standard way we've been teaching our most powerful AIs, the exact method used for years by all the biggest labs in the world, has a fundamental flaw? Well, today we're diving into a breakthrough that's shaking up the very foundations of AI training, all by fixing a huge problem that was hiding in plain sight. This is the question, right? It's the tightrope every AI developer has to walk. You've got this brilliant model, but every single time you try to make it better, more helpful, more honest, you run this massive risk of completely breaking the thing that made it so great in the first place. It's a super high-stakes balancing act between making progress and, well, total catastrophe. So how do you walk that tightrope? Well, for the most part, it's through a process called reinforcement learning. The easiest way to think about it is like training a very, very smart dog. The AI gives you an answer. If it's a good one, it gets a reward, like a little digital treat. If it's wrong, it gets a penalty. Now, just imagine doing that millions and millions of times. Eventually, the AI starts to learn exactly how you want it to behave. Now, for years, the undisputed king of this whole training game has been an algorithm called Proximal Policy Optimization, or PPO. The real genius of PPO is its built-in safety net. It basically forces the AI to only make small, safe changes, so it doesn't suddenly go off the rails during training. It's the reason our most advanced AIs stay on a pretty tight leash. And make no mistake, PPO is the bedrock of modern AI. It's reliable, it's trusted, it's the engine behind so many of the AIs we use every single day. But here's the thing. It turns out that even the strongest bedrock can have a tiny crack. And in the world of AI, a tiny crack can lead to a spectacular failure. So where does this super trusted method go wrong? Well, it all comes down to a really simple but absolutely critical mistake in how it judges what a safe change even looks like. Turns out the way it measures risk is surprisingly easy to fool. And this is where it gets kind of bonkers. Let's say the AI wants to use a rare word just a tiny bit more often. PPO sees that, calculates this huge ratio, and totally panics, slamming the brakes on learning. But then, the AI could make a massive, potentially dangerous change to a super common word, and PPO barely even notices. It's like having a security guard who completely freaks out over a fly buzzing in the room, but totally ignores an elephant crashing through the wall. And the researchers themselves, they just hit the nail on the head here. PPO's logic is completely backward, it's way too cautious when it should be flexible, and it's dangerously permissive when it should be careful. This isn't just inefficient, it's a recipe for things to go very, very wrong. This slide just shows you the problem in black and white. That graph on the left, that's the signal PPO is using to make its decisions. Look at it, it's chaotic, it's noisy, it's all over the place. It's like trying to navigate a ship in a hurricane with a compass that's just spinning wildly. Now look at the graph on the right. See how calm and stable that is? That's like a brand new GPS. And the shocking part is that for years, the entire field has been using the broken compass. Okay, so if the old compass is broken, it's time to build a new one, right? And that's exactly what these researchers did. They didn't just point out the problem, they built a much better navigation system. And that brings us to their brilliant solution. Meet Divergence Proximal Policy Optimization, or DPPO. The genius of DPPO is that it just zooms out. Instead of obsessing over the probability change of one random word, it looks at the change to the AI's entire strategy, the whole big picture. It's just a much smarter, more robust way of doing things. Let me put it another way. Think of PPO as that terrible micromanager, you know the type. They see one tiny, insignificant mistake from one random person and immediately decide the whole project is a failure. DPPO, on the other hand, is like the wise, experienced manager who looks at the overall team performance and workflow to figure out the real risk. It's just a way more intelligent way to lead. Okay, I know. This slide looks a little intimidating with the formulas, but trust me, the key difference is incredibly simple. That top formula for PPO, that's the one that gets fooled by this single noisy data point, or buzzing fly. But the bottom formula for DPPO has this little sanity check built right in, that little triangle symbol that looks at the big picture. It's just a smarter, safer way to stay on track. So the theory sounds great, for sure, but does it actually work in the real world? Well, the researchers put DPPO to the ultimate test, a head-to-head battle against the reigning champion and all the other standard methods. And the results are in, and honestly, it's a knockout. Those green and red lines, that's our new DPPO method. They are consistently dominating. They learn faster and they reach higher levels of performance. And check out that third graph. A competing method literally suffers a complete meltdown. Its performance just collapses to zero, while DPPO just keeps on cruising rock solid. And it's not like this was a one-off thing. It doesn't matter if it's a massive 30 billion parameter model on the left or a smaller, more nimble one on the right. In every case, DPPO just comes out on top. It's a clear demonstration of its raw power and its versatility. You don't have to take my word for it. The researchers' own conclusion leaves zero room for doubt. They said that across all their huge experiments, DPPO proved itself to be fundamentally superior in both stability and efficiency. It's a total game changer. And get this, the benefits aren't just in performance, they're also in money. Big money. DPPO is so much more efficient that it lets developers completely skip a major, really expensive step in the training process. That saves a staggering 25% on compute costs. In a field where training a single model can cost millions of dollars, that is a massive, massive win. Okay, so we've seen the science, we've seen the results, but what does this all actually mean for the future of AI? Let's zoom out and look at the big picture here and why this one little change could have huge ripple effects. Well, first off, more stable training means fewer expensive, time-wasting failures. That stability leads directly to more efficiency, which lets us build more powerful and capable AIs for less time and less money. And when the cost of building these things goes down, it opens the door for more researchers, more small companies, more creators to build the next generation of AI. It creates this amazing, virtuous cycle of progress. So here's the bottom line. By finding and fixing this one single hidden flaw in the very foundation of how we train AI, this research has basically cleared a new, better, and faster path for an entire era of innovation. It's an awesome testament to the importance of questioning our assumptions and a really thrilling glimpse into what's next for AI. It's a really humbling thought, though, isn't it? For years, PPO was considered the gold standard. It was just the way things were done. It really makes you wonder, what other best practices that we all take for granted today are just waiting for a rethink? What other incredible breakthroughs are just sitting there, hiding in plain sight?